Hey guys, how are you? And welcome to Just One More Linux. Today we are doing Cisco Packet Tracer Lab 9.2.4 Identify Packet Flow. This lab is part of the Network Security Netacad course. It can be found in Chapter 9. It is in part 9.2.4. And this is related to the firewall chapter, but doesn't really necessarily have too much to do with firewalls. It is more about identifying the flow of packets. In fact, we'll read the definition. In this packet tracer activity, you will observe packet flow in a LAN and WAN topology. You will also observe how the packet flow path may change when there is a change in the network topology. All right. So a little quick note about this lab, right? When you open it, they first want you to verify connectivity, okay? To do that, you're going to first open up PC0, right? But before we even do that, I'm just going to give you a little tip, right? You may have to press the fast forward button right here a couple times. It's all the way in the bottom left, right above the toolbar. If you just hit that up to about 10 minutes, you should have zero issues resolving these websites. So this whole first part right here, verifying connectivity, you're just going to open the web browser on PC0. And you're first going to go to Cisco, www.cisco.pka. Okay, and this is supposed to resolve, and you can speed it up again by hitting that fast forward. And it resolves. That's what it looks like. Okay, and then we're also going to go to www.web.pka. Okay, hit enter. Okay, I honestly probably not 100% sure because they're exactly the same. Oh, yeah, never mind. The word changed, of course. So it's not exactly the same. It's very close. But the word did change to web, so that one resolved as well. All right, and they're supposed to. If for some reason you have an issue, because this is actually not my first time doing this lab, and I did have an issue the very first time I did it, you can actually go up here to File and hit Reset Activity. And then as soon as it comes up, I recommend just hitting the fast forward button down here a bunch of times, up to like 10 or 15 minutes. And hopefully that should help you out. I haven't had an issue with it any of the other times I've started it. It was just the first time. And that was the solve for it. All right. So going further, before we get into part 2 here, that was the whole part 1 right there, just verifying connectivity. So our connectivity works. Before we get into part 2, I want to say, so we tested Cisco.pk and Web.pka. If we look at our topology here, we can see we have a server for each, right? Over here in what they call public network, we have Web.pka and a public DNS server. And then over here in this pink one that's unlabeled for some reason, I can't tell you how much it bothers me that they labeled this one, but not these other two. We have, in the pink, we'll call it the pink network, we have Cisco.pka, okay? So, we're going to dissect the traffic. So the first part in step 2, we're going to switch to simulation mode, okay? Simulation is down in the bottom right. You're going to click that. And then they want us to click Show All None to reset the filters, right? And then we're going to go to Edit Filters. And what that does is it removes all of the checks from these boxes, right? So when you click Show All None, if there was any checks on any of these boxes, it removes them, okay? And then it wants us, though, in IPv4 to select DNS right there. And then in miscellaneous, we're going to select HTTP. Right, because we want to filter for those packets and not see a ton of other junk, right? We're just really looking at DNS and HTTP in this lab, okay? So we're going to close that. after that's set up, and we're going to open up PC0, and we're going to go to the web browser again. And now we're going to go, I forgot, to web.pka first, okay? So first, let's type it in, www.web.pka. Okay, before we hit go, or I guess we can because it's simulation mode, we'll hit go. It's going to say here, predict the packet path to resolve www.web.pka to an IP address. Record your prediction. So how do you think this is going to go? What packet, or what path is our packet going to take to resolve this web page? And how exactly will it do that, right? So I'm going to start clicking next to this. We're going to follow our packet. All right, we see our little brown envelope here traveling, leaving the network. Okay, now we're entering into what they have labeled the public network. We're getting up to switch 0. Here's where it comes into question. Which way will we go? All right, we have 2 ways to go. Which way will we go? What do you think? All right, I bet a lot of people didn't see that coming. All right, and then we have this packet here fails, okay? And we go on further, okay? And now that we grabbed that, we see this fails too. So let's click that open and dissect it. Let's see what it says. Let's see what because that was our destination, right? It says gigabit Ethernet 0 receives the frame. The frame's destination MAC address does not match the receiving port's MAC address, the broadcast address, or the multicast address, and the device drops the frame. Okay? So what information is this packet carrying? This packet is the DNS request, right? It's grabbing the IP address of our website. So now, we see our website still hasn't resolved. Now, when we get back to the switch 0 this time, what happens? Where do we go? We go to switch 1, and then we don't go to the public DNS server. We go to our website. And now we're good, okay? So then when we get back here and travel back into our network, back to PC0, this is when our page will resolve. Ready? Here comes the magic. There we go. Now we can see our website. And this is when we're going to get an annoying message called buffer overflow. This is because there is too much going on, and it's kind of like out of memory, so to speak. Just because we're filtering only DNS and HTTP, there's a ton of other stuff in this list. So if we want to review more, we can click View Previous Events, or we can choose to clear the event list, right? So we're going to click View Previous Events for now. But keep in mind that we can't go forward anymore, right? We can only review the past at this point. The simulation panel in the event list is full now, okay? So let's continue on down our steps here. Where were we? I think we were in step D. Click Capture Forward until the web page is displayed on PC0 to view the packet flow. Click View Previous Events when prompted by the buffer full dialog box, which we did. After the IP address has been resolved, which path did the HTTP packets travel to display the web page? Record your observations. So we saw that we first went to the public DNS server, we got the IP address, and then we went and we actually resolved the web page, okay? Switch to real-time mode and click the X icon in the right tool panel to select the delete tool, okay? So we're gonna switch back to real-time. I'm gonna close this for now, and we're gonna actually delete, right? You can also just hit your delete key, which will turn your pointer into the delete tool, okay? Now be careful. All right. are we supposed to delete here? Click the X icon on the right to turn the delete pool. Remove the link between switch 0 and switch 1 from the public network to simulate a broken link. So what it wants us to remove is this line right here, okay? And then you're going to go back up here. Follow my mouse. I'm right here. Go all the way back up to the top by where logical and physical are and click this first one called select, which will turn your tool back. All right. After about 30 seconds, the network will learn of the broken link. You can click fast forward to speed this up. So come down here by where the fast forward button is again and click that a couple times. It says 30 seconds. I like to overdo it just to be sure. And then it reminds us, as we just did already, select the arrow tool above the delete tool to deselect delete. So if you didn't do that, make sure you deselect the delete tool and go back to your regular pointer. And now we're going to switch back into simulation mode. And we're going to take the tablet this time. We're going to go to the desktop, go to web browser, and this time we're going to use our tablet instead, and we're going to go to www.web.pka. Now, honestly, the tablet really doesn't have much of an effect on it. It's a little bit different the way the wireless communication here works. But what it really wants us to focus on is what path will we take this time now that this has been deleted, right? So this link between switch 0 and switch 1 is now gone. What way is our packet going to go? We can see our little packet right there is popped up on tablet 0. Hit next. We're going to go to the wireless router, and then we're going to start heading out there. Now when we get to switch 0 here, this is where the change is going to happen. Obviously, there's nowhere else for it to go. Okay? So we're going to go to switch 2. Now at switch 2, what's going to happen? All right? And we're going to see that web.pka will get a packet like we read last time. Okay? That's the same packet that we read last time. The frame's destination MAC address does not match. It drops the frame. Okay? And then our other packet goes on to retrieve that critical information. Okay? And we're going to go all the way back to the tablet. And then now we're going to send out another packet, this time directed for web.pka. Thank you, network address translation. We're going to keep going. And then we're going to hit the server. This time it's successful. And we're going to go all the way back to our tablet. And right here, boom, there's our website. Okay? So, with a broken link in the LAN, how did the path change? Record your observation. To be honest, it shouldn't really be that surprising looking at the network topology. Maybe before watching the first one it might be, but after watching the first one, it's not anything crazy here. There isn't even really another path for it to go, although I guess it could fail. It doesn't, right? So there's the change that we're making note of. Let's clear simulation mode here. Let's see, reset simulation. And then we're going to head on to part 3, WAN network topology. All right. Remaining in simulation mode, open a web browser on PC0 and go to Cisco.pka. Okay? So now we're going to open the browser. And we'll go to www.cisco.pka. Okay, there we go. Our little our little packet pops up. We're going to hit this top checkbox in the bottom to make sure we don't lose our window. All right. And I'm going to go quick here. Okay. Well, wait. Weren't we going to Cisco.pka? What are we doing? Remember, we have to get the information from the DNS server first. And I actually meant to ask that question before I started clicking go, but I got a little too excited. I wanted it to be a challenge. I meant to stop at router 5 and say, now which way will we go? So now we have our information from the DNS server. Now, when we get to router 5, which way do we go? Of course, we go on to router 2. We're going to go straight across to 4, okay? And then we're going to go there and to the web server and grab our website information. And that packet's going to come all the way back. 1, 2, 3. There's our website, okay? So we did this. We predicted the path. I kind of messed that part up a little bit, but that's okay. We'll have another chance to predict the path. Don't worry. I clicked the capture forward until the web page is displayed. We did that. After the IP address has been resolved, what path does it take to display the web page? Record your observations. So it's just the same, honestly, as WebPKA, except it's on a different network. We first went to the DNS on the public network and grabbed the IP address. And then using network address translation, we went and grabbed our website from Cisco.pka. All right. We're going to switch back to real-time mode and remove the link between 4 and 2 from the topology to simulate an inaccessible path. The routers are using an enhanced interior gateway routing protocol to dynamically adjust routing tables to account for the deleted link. All right, so go to real time. I'm not 100% sure. I guess maybe you can't delete stuff in simulation mode. I'm not really sure. All right, so that's what we're supposed to delete, is that link in between 2 and 4, okay? Switch back to the regular tooltip. All right, and then on D, we're going to switch back to simulation mode and open a web browser on tablet 0, okay? So just the same as kind of the last one. Now we'll open tablet 0, open the web browser, and we're going to go to Cisco.pka again. This one is not really that eventful, since we kind of already know what's going to happen from the first one. Which way do you think it'll go, though? Do you think we'll go around router 3 or 1? All right, let's hit go. And I'll read this too as we go. I'm going to hit play, let it go by itself a little bit. With a broken link in the WAN, how would the path change? Record your observation. All right. So let's watch it go. Speed it up a little bit. We get our IP address. All right. Now we actually go to Cisco.pka. When we hit router 2, which way are we going to go? To 3, and then to 4, and then the rest we can predict. Okay? We actually lost our window there. You got to always remember to hit the little top checkbox right here, or you'll lose the window. All right? And then there we go. There's our information coming back. Here we go. Bam. Okay? So we have the buffer overflow again. If you wish to review any of the information from that, we can click, hold on, view previous events, which I'm going to do just so we can go back here and we can see when we first hit router 2, what that decision looks like on the packet, okay? So on layer 1, serial 011 receives the frame. Then the device, on layer 2, the device de-encapsulates the payload from the HDLC frame and sends it to the upper layer. The device looks up the destination IP address in the routing table. The routing table finds a routing entry for the destination IP address. Destination network can be reached via 192.0.2.17. The device decrements the TTL on the packet. The device encapsulates the packet in an HDLC frame. and then it sends it out. Okay. So if we look, this is about where the decision was made. And this right here is 192.0.2.17 on 001, right? So right here at layer 3 is where the decision was made of which way it will go, okay? And that's about the only thing interesting to look at and dissect, okay? And after that, I'm just going to close this out and then reset the simulation just to clear that out. And then we're going to go on to step 2 of part 3, PC1 to websites. Now this is where it gets a little more interesting in my mind. Here we're going to click PC1, okay, which is in this area over here on the same network as our Cisco.pka server. Remember to check that little top checkbox right there. And we're going to go to the command prompt. Okay. And we're going to open up a tracer. We're not going to open up anything. We're going to type out tracer www.web.pka. Now, if you don't know what tracer is, it's kind of similar to ping. Although I do have to wonder if you're not sure what tracer is, why you're watching this lab, honestly. Although I guess this lab could be informative to somebody who's just starting out. But yeah, if I don't have a video up yet about tracer on my channel, which I plan to probably have one up by the time I would release this, but if not, there's a ton of content on YouTube surrounding tracer. I'm sure there's endless amounts of videos. But I'll briefly describe what it is here. It's very similar to like ping, right? But tracer actually follows the path and shows us the path that it takes to reach the destination, right? It shows us the next hop to reach each destination. Okay, so I'll press enter. We can see what that looks like. All right. I don't know if I'm supposed to be in simulation. Oh yeah, we're supposed to be in real time. Oops. So there we go. We can see it coming through. All right. And the trace is complete. And there's a reason that they want you to see it in real time. All right. So that part C, match the IP address in the tracer results to the devices in the topology. Hover over the routers in the topology to view the IP addresses of the interfaces on the routers, which is why they don't want you to use simulation mode when you send the tracer command, because what would be the point of asking this question then if you use simulation mode? Obviously, it would show us. If the pop-up does not stay active long enough, you can access router IP addresses in the following manner. Click the router CLI, press enter, now enter the command show IP interface brief, blah, blah, blah. Okay? We're not going to do all of them. I'll hover a few to show you. So the first hop from PC1 is going to be the west router right here. Okay, so we're going to hover. We're going to highlight that. This is what we're looking at. We're looking for 192.168.0.1. Okay, and then as you can see on port gigabit Ethernet. Sorry, let me hold it steady. Gigabit Ethernet 01. Jeez. On gigabit Ethernet 01, we have 192.168.0.1, which matches our first hop, right? Okay, so then the next hop is going to be 209.165.200.225. Can we get it? I really wish it was easier to hover on these and it wasn't so finicky. All right, so then we can see on serial 00 or 011, we have 209.165.200.225. Then we know that it went to router 3 next. Oops, forgot to click the window. Okay, so we can see 192.0.2.2 is on serial 000. Okay, and so on. And it's going to keep going down, right? On router 2, we have 218 on 001, okay? And then I guess we might as well just keep going at this point. On 192.02.26, all right, 192.02.26 is on 011. All right. And then this is where it's going to differ. Okay. So then next, we're going to 209.165.202.132. All right. And we can see that the network is correct, but it's 130 instead of 132. Okay? And which address is 132? Okay? So this is actually 132, even though it doesn't show us that, right? We get it from here. So here's 131 is the public DNS. Now, I'm going to actually not explain this anymore because I'm kind of ruining the next part. And I totally forgot that, but we're going to keep going here. Okay, so that's what tracer does, right? Tracer shows you the next hop, right? So the final hop here, okay, is right here. All right, and next we're going to figure out how that's possible. Okay, network address translation is used to translate the private www.web.pka IP address of 192.168.2254 to a routable IPv4 address of 209.165.202.132. Okay? So, if we look here, right, we can see the private address is 192.168.202.254, like we see here. Okay? And that is because of network address translation. Okay? Where did I leave off? In the tracer result, the first line of the IPv4 address 209.165.202.132 is for the G01 interface of east. The second line of IPv4 address 209.165.202.132 displays the public IPv address of the web server. Okay? So these, even though they have the same address, are actually two separate hops, right? So the first one right here is east, which is right here. And then the second one is right here. And network address translation changes the private IPv4 to the public IPv4, okay? So switch to simulation mode, open the web browser on PC1, and enter www.web.pka as the URL, and click Go. Click Capture Forward to load the web page. Compare the tracer results to the simulation results for the HTTP packets. Record your observations. All right? So this is where we're going to see how that network address translation takes effect, actually, okay? So let's put this up here. All right. Save that for later. Go to simulation mode. Okay. We can't save it because we got to go to the browser. So let's go to the browser. www.web.pka. All right. Oh, not PKKA. It's going to be PKA. Sorry about that. We're going to hit go. All right. And we see our little packet pop up. All right. Now the first leg of our trip is going to do what? We're going to hit that DNS server, okay? Now again, we do go to web.pka, but it doesn't match the destination. All right, we're going to come back. Now, why don't we see any of this in Tracert? We actually do, okay? So we know what happens for the rest of it, right? The rest of it is almost completely identical to Tracert, except we can see these last few hops, you know what I mean? And we see it touch every device in between, whereas Tracert does not, right? But what is that whole first part left out where we resolve the IP address? It's not. And hold on, let's clear the buffer here again. It honestly annoys me that they have to do this every time. And we're just going to click clear because we don't need to review the past events. All right, so we can go back to Tracert. That whole first part where we go to the public DNS server and get the IP address for the website, that whole first part actually takes place right here, okay? Now, if we do simulation mode, we can see that, all right? So we're gonna press up. We're gonna stay in simulation mode and press up. And we're gonna go, right? So we send the command, okay? Now you're gonna notice that nothing is going to happen on Tracert. We're not gonna see anything returned, no value whatsoever until this packet gets back, okay? Now we have the destination IP address. So we're tracing the route to this server, okay? Then, buffer overflow again, of course. I can't show you what the rest of it looks like because we keep getting, let's see if we clear, if we can keep going. Nope, it just goes through it. Let's see if we can get this to work. So I would really like to show you the rest of it. It's kind of a shame there. And it's going to crash every time. Okay, well, the big difference there is that first leg actually happens in that first command, okay? This first part right here is actually representative of that whole first leg we see when we watch it in simulation mode, okay? And that's it. That's pretty much it. That is the lab. That is it. There's nothing else here to do. That is the end. Good day. Have a nice one. Have a good evening. Whatever it is in your area, I don't know. Hopefully you learned something here. Hopefully you enjoyed it and had a good time. Have a good one. Thank you for watching.